Hi everyone. Well, today I'm going to be doing a little bit of process development. Seems like I have a lot of projects that require cooling fins, and since I'm a lost foam caster, I decided I was going to do a little process development to improve my capability as far as castings with cooling fins. In the past, what I'd been using was one of these finger joint bits, and it works pretty good. You can see the tapered grooves it cuts, but it can only cut about 3/8 to a ½ inch depth of fin, and it can't cut a very fine fin. It turns out, cylinders that look like this, which, it's not bad, but the spacing and thickness of the fin is slightly over 1/8 of an inch at the root. And I wanted to get a little bit higher fin density and cooling capability than that. So I was looking around and I really couldn't find any ready-made bits that would do it, but I saw these saw blades for these little battery-powered circular saws, and if you buy 20 of them or so, you can get them for less than $2 a piece, somewhere between $1 or $2 a piece. So I bought some of them, and we're going to use them with the arbor. I had a arbor for my ½ inch router here, ½ inch bit. I made a little adapter that was the ID of the saw blade, and then I turned a whole bunch of spacers from various washers and shim stock so I could space the blades however I wanted to. And I cut those and made some lost foam samples that you see here, because I just wanted to see how the varying thicknesses would cast. And turns out that when you get down to the thinnest setting, which I thought was going to be about 60 thousandths, these were where I had partial success on these, and the blade actually cuts the fins a little thinner and the space is a little wider than what you measure on the cutter. But the way these were hung on the tree, this was down and this was up, like this. And you can see the one that had the fins pointing up didn't fill as well as the one that had the fins pointing down. And that might be partially because of the orientation, but I think it was mostly because this one was deeper in the mold and had more head pressure. And I wasn't using any vacuum assist. This is just gravity-fed lost foam casting. So the other thing to note is these fins are 1¼ inch deep. So I said, well, okay, it looks like maybe 1¼ inch might be kind of the outer realm of what you can do in lost foam with this technique and that size cutter. And keep in mind, in lost foam, you don't have bound sand. It's just sand that's vibrated in place, loose sand that's vibrated in place, and it's an unbound mold. So it's actually, to get that kind of, that thin of a fin, which is about 50 thousandths and 1¼ inch deep, it's actually seems to me like a fair accomplishment in lost foam. But with that experience, I decided to make up some sample patterns, and heat sinks and engine cylinder heads, anything from model airplane engines all the way up to full-size 1-liter motorcycle engines are things that are of interest to me. So I did some setup parts, and I made like a 4-cylinder small model engine cylinder, this setup part. And I also made just kind of a mock motorcycle cylinder here out of a couple of pieces. And I did that on my overarm router, and I just use a pattern like this. There's a pin in the bottom underneath the bit that engages this wooden pattern, and I mount a block of foam on top, and I cut the various pieces with pattern cut them like that. I'm not going to go into that, the actual pattern making very much today. I'll just show you the resulting patterns that I got from that. But you saw the setup pieces there. Here are a couple examples of what I'm actually going to cast today. So here's the lost foam pattern of, you can envision this as being maybe a overhead cam single cylinder motorcycle cylinder. It's got a bore of about 3¼ inches, and it would fit inside a 6-inch cube. And when I pack it in the mold, I'm going to orient it like this, and I'll show you a little bit of video here of how I pack the molds. It's a little bit of repetition from some of my other videos, but for completeness in casting these, I'll include it here. And then similarly, for the smaller parts, these would be like model airplane size cylinders here. And like the setup part, I made a 4-cylinder inline. And even though this is model airplane size or small scale, you could see that this motorcycle cylinder could just as easily be in inline 4, and that would be at a 3-inch bore. A sport bike, a 1-liter sport bike doesn't even have 3¼ inch bore, so it's easily of the size that you could cast, big bore jugs for a motorcycle if you wanted to on that. So between that and heat sinks for cooling, a lot of times my castings need cooling fins, and these cooling fins are pretty high density, so I think they do a pretty good job. The ones here on this cylinder are about 3/4 of an inch deep, and the ones on this one are about 1/2 inch deep. So being half the depth of this one that I got to fill, I'm hopeful that I'm going to get a pretty good result from it when we cast them. So the only other thing that I'm going to do before I start molding these is that just for the sake of handling them and keeping them sturdy enough, I don't put much of a sprue length on them. But then I make this sprue material. I've got a tenon cutter that I just plunge and glue together to come up with sprue stock. And I'll just add sprue stock to it to get a little bit more head pressure and depth into the mold when I bury them. And I've got a pouring cup and a few other features that I'll go into in the packing process. But that kind of gets us to the point here where we've got these patterns. And I should mention too, you probably noticed they're a different color than the pink foam, and that's because they've been dip coated in a refractory slurry. And the reason you do that is it controls the rate at which the foam evaporates and the gas escapes for a more controlled pour. Gives you a good surface finish and prevents sand inclusions from burning in to the aluminum casting itself. So you get a nice clean casting with a surface finish that's equivalent to the surface finish you were able to achieve on the foam pattern. So other than that, all we're going to do is pack them and pour them, and I'll be back with you on that. Stay tuned. All right, so we're going to mold the foam patterns. Maybe just a little recap of my Lost Foam mold packing rig. I made this little device here, which is just a dolly. It's got a turbine vibrator on it. The vibration excites the sand and packs the sand nicely. I just got a air chuck and a valve on there for that. The other thing it's got, the feature we won't be using today is it's got a vacuum source for it. And this little hole right here, I've got a sealing gasket that fits between the molding rig and the bottom of my flask here. There's a perforated plate and then a fine stainless steel mesh screen in there. So if I ever want to pull vacuum on it, I just sit the flask on there, pull vacuum, you pack the mold up to a certain height, and then you put a thin film like a piece of visqueen or a plastic bag in there, and then put an inch or two of sand on top of it, and that thin film layer acts as the seal, and you can pull vacuum, and depending on your vacuum source, you can pull whatever amount of vacuum you want. Today, I'm not going to be using that because I just don't think I need it for it. But as far as the sand, it's just, I just use sand I get at the big box store. It's fine, dry, and sifted sand. You can see it there laying on the side, quick creep. There's nothing special about it. I don't know what the mesh is. I'm guessing it's probably about 50 mesh though, or so. But anyway, I'm just going to put a little bit of a bed of it in there for the pattern to sit on, and then we'll start the packing here. So here's the pattern, and get them set in there about right. A little in there to get her in the right position. That looks about right. And then I just kind of ladle it in there for now. We'll get it partially full, just so the patterns are stabilized. And I like to just fill it up first, just to get them, just get the patterns buried. kind of dusty sand. So let's see here. That's up just to the bottom of where the sprue begins. And then it's going to get noisy here. I'm going to turn on the vibration. For the sake of time, I'll fill this up. I'm going to fill it up, and I'll probably rejoin you here with a little bit of video just to show you the pouring cup. But I fill it up right to the top of the sprue, and then I got a pouring cup I sit on top of there, and we'll pick that up next here. Alright, so I'm back with you. I've packed the mold, let it vibrate for about 4 or 5 minutes. It's packed right up to the top of the sprue there. And then I use these reusable pouring cups that I've made. They've got a little weir in the bottom there you can see, and a pouring well. They're made from moldable ceramic fiber, which is completely unwetted by molten aluminum, so I can reuse them. And then this is just a little sheet metal lifting bracket that I have there that after I pour it, I can grab it with a pair of pliers and pick it up and dump out the residual aluminum that's in the pouring well, because after the mold's filled, that's not doing anything for it, and I have to do that in order to be able to reuse the pouring cup. But I've used these, I don't know, this probably got 50, 60 pours on each one of them. I got a couple of them that I made, but all I do is just literally just set them, put the bracket on and set it on the top of the sprue, kind of wedge it on there a little bit, and then I'm just going to fill around it a little bit, get a couple inches around it so we don't have any runouts there, and then turn the vibration on again, and it'll just finish packing this last couple of inches. So hold on just a second here. And then just hit it with a little more vibe. And that's pretty much it. This one's ready to pour. I'll repeat the process in another flask for the larger cylinder here, and I'll have 2 flasks packed, and I'm going to try to get both of these from 1A10. It's actually going to be pretty close. I may have to do a little calculation to make sure I don't come up short on the second pour. That wouldn't be too cool. But anyway, I'll pack the other mold and get them both ready to pour and staged outside. I've got the metal in the pot right now, and the furnace starting to heat up, so next thing we'll be doing is casting them up. All right, we got the molds packed up, we got the metal at temperature, did the final skim, took a temperature reading on the metal. I think we're ready to rock and roll, so I'm going to try to pour them both at the same time. I think I got enough metal in the pot to do it. Fingers crossed on that. Let's see how it comes out. Alright, well that seemed to come off okay. We'll let them cool and then we'll shake them out and see how we've done. Alright, well it's time to demold them. We'll see what we've got. Demolding's kind of a fancy name for just dumping the bucket on the ground for a lost foam casting, but time's here, let's see what we got. Yeah, looks like it's mostly there. I'll quench it and clean it up a little bit here. Get this one out of there. Yeah, it also looks like it's a good casting, but we'll get it cleaned up here. Got to quench it. Right, well, you can see that this one looks pretty darn good. So anyway, I'll do a little cleanup here and we'll take a closer look at them after I get them cleaned up. Alright, well, I've got them cleaned up and let's have a look at what we got. First, I thought I'd just show you that pouring cup. I can just pull the skin out of it. You can see the shape of the pouring cup there, but grab a set of needle nose pliers and you just kind of pull the aluminum foil out of there and it's ready to use again. So there's that. Let's see, well, let's have a look at the little ones first. You can see I cut the gates off the top of this one here. And you know, I think it came out pretty darn good. You can see it here. One little spot right there where it looks like, I don't know if you can see it or not, it looks like I just cut the pattern too thin on that. I think it gets down under a 1/16 of an inch there, but outside that, you know, the rest of it looks pretty darn good. Nice little casting. I'm kind of surprised. Came out well on that. Same thing with these here. I mean, same one. They look pretty much the same, but you can see, if I can hold it so you can see through the fins there. Yeah, you know, so not a bad little casting. For the amount of effort I put into the patterns, you know, pretty good, I would say. But yeah, so I'm saying 50,000 spins, ½ inch deep, they look doable. At least on these they were. And then let's take a look at the bigger casting. This is actually a pretty nice casting. I made the fins a little thicker on this one. I mean, they're about, I think they're about 70, 80 thousandths. This one right here is where I built the stack up. It's a little thicker. But you can see this is a nice solid casting. And if this were an inline 4, you know, I'd heat treat this casting and I'd machine it and I'd run it without hesitation. You know, I got the bosses here for mounting studs, and it's just a simulated sample part, but it's a pretty solid casting. So yeah, you know, lost foam is not bad at all for putting metal where you want it. It's fast. Doesn't take a lot of overhead as far as machinery and equipment, and you can do some pretty decent detail with it. So I think I'm going to call the process development for thin fins a success. And in the future, if I want to cast some air-cooled engine cylinder heads or you know, some cooling fins and heat sinks, I won't hesitate to use that tooling and that technique. So thanks for watching, and until next time.